So chemists, it's Mr. B here, and this is the first video I'm going to make to go along with practice and such throughout the stoichiometry unit and what's to come. I want to remind you all that if you have any questions at any point here, you can email me. The email is on the Google Classroom, but it's Mr. B Science MB, Mr. B Science MB at gmail.com. You can find that on the Google Classroom. And also continue to check back on this channel because I hope to keep adding videos to this quite regularly. Um, so without further ado, we're going to start with one of the more introductory stoichiometry problems that we were looking at last week. These are ones that don't have grams or liters or number of particles or anything, just straight up moles to moles. At any point in this video, I do recommend that you pause it and kind of like work ahead just as I'm about to solve something, because then you can immediately check your work and I'll explain what type of stuff we're thinking about. Anyways, here we're going to read this question. It's saying that we have a reaction that has nitrogen gas, that's N2, over here, reacting with hydrogen gas, H2, to create NH3, which is ammonia gas. So here it says how many moles of ammonia are made if we react 2.00 moles of molecular nitrogen, which is this nitrogen gas here. I'm just going to draw your attention over here. I think it's going to start shaking as I click. Let's see. Oh yeah, there we go. So our first thing in every single Stoic problem always is to make sure the equation is balanced. Then we're going to figure out what we know, add conversion factors, make sure that we have to cancel out what we need to cancel, and get what we need to get as far as units go. Then we're going to multiply tops and divide the bottoms on your calculator. So take a look at that reaction there. Does that look balanced to you? Feel free to pause the video here for a second and try to get that balanced as best you can. Then when you're ready, just keep going and I'll show in a second. So that was not balanced originally, but now it is. So see here now, we have 2 nitrogen on the left side because N2, 2 nitrogen here, 2 in each, 1 nitrogen each ammonia, so that's 2 and 2. Then for hydrogen, 3 times 2 equals 6, and 2 times 3 equals 6. So we have 2 nitrogen and 6 hydrogen on either side of the equilibrium arrows, either side of these arrows right here, which means our reaction is balanced. So that means we are good to go. Now, take a look at this question that it's asking us. What do we know? How many moles of ammonia are made if we react 2.00 moles of molecular nitrogen? Well, what this means is we're going to have to look for a number, and the number it's giving us is 2.00 moles of molecular nitrogen. And what it's asking for is moles of ammonia. So we're given 2.00 moles of nitrogen. Our conversion factor is going to be the molar ratio. That's going to be a key thing in all of stoichiometry. So you're going to be using this molar ratio, or moles to moles, in the middle of every problem to go from data about one thing to data about another, as far as compounds and the reactions go. And then we want moles of ammonia. So we're going to have to convert moles of nitrogen to moles of ammonia. And just to map this out, we only have one conversion here because we're already in moles and we want to get moles, we're already in moles, we want to get moles of another. So that's just a mole to mole conversion, which is a single step problem. So I'm going to draw one arrow here. You'll see in further videos we'll end up with more arrows, and that just means more steps. But for now, one arrow. And we're going to circle that because each arrow or each conversion requires its own conversion factor or its own step. So with that in mind, feel free to pause the video here and try to map out how you may convert 2.00 moles of nitrogen to an amount of moles of ammonia. So here is how we set it all up. I hope you had time to pause it here. But anyways, here we have 2.00 moles of nitrogen. Then we're going to be looking at the coefficients from this reaction up here. So we know that there's 2 moles of ammonia because the coefficient's 2. For every 1 mole of nitrogen because the coefficient's 1. This makes sense because if you think of the whole reaction as like one whole, like baking one cake or making one sandwich, whatever it is, it's saying that we spit in 1 nitrogen and we get out 2 ammonia. So relatively, for each time the reaction happens, there'll be twice as many moles of ammonia because you're getting 2 out and you're only putting 1 nitrogen in, which means we have 2 moles of ammonia for every 1 mole of nitrogen, which means the molar amount of ammonia will end up being twice as big. So 2.00 moles times 2 over 1, or times 2 divided by 1. We get 4.00 moles of ammonia. So this is our final answer to the problem, and we'll see this works out because we're going to cancel moles of nitrogen, and we're going to be left with this moles of ammonia as our final unit, and that's what it was asking us for up here. How many moles of ammonia are made? So feel free to play this back if you like and try to set up your practice problems in a similar way to this. That's great. And also, if you have any questions about this or any requests for another video you'd like me to make or a certain problem you'd like me to make a video on from practice, anything like that, feel free to drop me an email. Anyways, good luck, chemists. And yeah, Mr. B out. Take care.